Hi, let's look at section 3.3 homework problems just to make sure you have a good handle on what is expected for this section. I've chosen here problems to work from section 3.3 in my math lab. If you have any questions about the textbook problems, don't hesitate to contact me with those. So the first problem that I'm working is number 2, and it's given the graph of f of x, solve where f of x is greater than 0 and where part B is where f of x is less than 0. So remember how that we can use the graph to actually come up with our solutions. To find the first solution where f of x is greater than 0, remember that we're looking at where the graph lies above the x-axis. And it lies above the x-axis in this region and in this region. So we've got to think about what values of x does that correspond to. Well, that is to the right of 8 and to the left of 6. Now, can we include our endpoints here? No, being strictly greater than 0 means we have to exclude our endpoints. So our solution would be where x is less than 6 or where x is greater than 8. Now in interval notation that would be written as negative infinity to 6 union 8 to infinity. Okay. Now where is it less than 0? So for part B it is less than 0 in the region between the 6 and the 8. So we would say where x is between 6 and 8. Or in interval notation, just parentheses 6, comma 8. Okay? Now, number 3 says to answer the following question by referring to the graph, and I've enlarged the graph because I thought that one was very difficult to read. It says, what is the solution set of g of x as less than 0? Well, g of x being less than 0 would imply that part of the graph needs to lie down below the x-axis. Well, that never happens, and so the answer to that would be the empty set. Now, what is the solution set of g of x is less than or equal to 0? Well, now it changes because we can include where it equals 0. Where does it equal 0? Yeah, that's where it lies on the x-axis. And we're answering with the value of x, so it equals 0 at the value of 6. So that is not an interval, it is just a set including the value of 6. Solve the inequality analytically. So to solve it analytically, this is where we have to find the solutions to the equation. So we have to say where x squared minus 13x plus 22, sorry, I'm using a new graphing tablet here, is equal to 0. Well, we try first by factoring and hope it does factor, and I believe it does, right? What are the factors of 22? Whose sum is 13. Yeah, that would be 11 and 2. Now the sum here means that we have the same sign here, and both of them are negative. So we know that either x minus 11 is equal to 0, or x minus 2 is equal to 0. Sorry that that's making that connection. That should be the number 11. So x is equal to 11, or x is equal to 2. Now we're not done, right? That's just the solutions to the equation. To find the solutions to the inequality, we have to place those numbers on a number line in sequential order, and then we have to test a region out of A, B, and C in the original problem. So out of region A we can test what value? Yep, my favorite number, right, which is 0. So if we plug in 0, is 0 squared minus 13 times 0 plus 22. Is that greater than 0? Yes, that gives us 22, which is greater than 0. So region A, test true. What's the number out of region B? Anything between 2 and 11, so let's say 3. So we would have is 3 squared minus 13 times 3 plus 22. Oops. Is that greater than 0? Well, that would be 9 minus 39, which is negative 30, plus 22, which would be a negative 8, which is definitely not greater than 0, so that doesn't check. And a number out of region C, anything larger than 11, so let's say 12. So is 12 squared minus 13 times 12 plus 22 greater than 0. So if you get out your handy dandy calculator if you need to here, 12 squared is 144 minus 13 times 12 is going to be negative 12 plus 22, and we get 10. And 10 is greater than 0, so region C checks. So we know that region A and region C include our solutions. We cannot include the endpoint because we're strictly greater than. So our solution set would be C, negative infinity to 2, union 11 to infinity. Now, number 4 is to solve the inequality 6x plus 7 is less than x squared, and again to do that analytically. So we want to find out here where 6x plus 7 is equal to x squared. So if we set it to 0, we would have x squared minus 6x and then minus 7. And this one does factor, right? The factors of 7, whose difference is 6, would be 7 and 1. We need different signs because of the difference, and the larger one being negative. So therefore we get that x minus 7 has to equal 0, or x plus 1 has to equal 0. So x would either be 7 or negative 1. So we're not done. We got to test on the number line where we have negative 1 and 7. So out of region A, if we label these A, B, and C, out of region A we can test a number to the left of negative 1, so that might be negative 2. So if we plug in negative 2, we would have is 6 times negative 2 plus 7. Where are we plugging into the original problem? Is that less than negative 2 squared? So we would get negative 12 plus 7 is negative 5. Is that less than 4? And yes, that is correct. Out of region B, we can plug in the value of 0. So we have a 6 times 0 plus 7. Is that less than 0 squared? 0 plus 7 is 7. Is 7 less than 0? No. And then what about a number out of region C? Let's see if I can squeeze it in down here. A number out of region C would be a number to the right of 7, so maybe 8. You probably know what it is, but we'll say 6 times 8 plus 7. Is that less than 8 squared? So that's 48 plus 7 is 55, which is less than 64, so that does check. So our solutions in this problem would be in regions A and in region C. We cannot include the endpoints because it's strictly less than. So we would have negative infinity to negative 1 union 7 to infinity. Okay. And let's look at one last problem. This function can be used to estimate the number of workers in a certain industry in the United States in millions, X years after 1980. For what years were there or will there be 9.2 million workers in this industry? And so what this is asking us to do is asking us to replace this W of X with 9.2. And so therefore we've got to solve the equation negative 0.01 x squared plus 0.21x plus 8.10 is equal to 9.2. Well, to do that, what should we do? Yeah, probably definitely use a quadratic formula. We would need to set it to 0 first if you like. So we'd have negative 0.01 x squared plus 0.21 x, and then we've got to subtract 9.2 from 8.1. So when we do that, we would get a minus what is that, 1.08? That's not right. I can add, that would be 1.1. Yep, 1.1. Sorry about that. And that would be equal to 0. Now if you don't like the decimals and you don't like the negative sign, we can go through and multiply everything through by negative 100. And in doing that, we would get just a 1x squared, then minus a 21x, and then plus, what would that be? 1.1 times 100 would be 110. And that's equal to 0. So now we need to factor that. And if we try to find the factors of 110, whose sum is 21, we would find 10 and 11 to be the result of that. And so this would factor as x and x, 10 and 11, and both signs have to be negative, so we get that either x is 10 or x is 11. So what years will that happen? X years after 1980 would be 1990, and 1991 would be when there would be 9.2 million workers. And understand that that parabola is opening down, right? That's what it means to have a negative coefficient leading. And so since that negative coefficient is leading, we would have possibly 2 points, which we do, where it is equal to 9.2. Okay, and that happens in 1990 and 1991. If you have any questions on this, don't hesitate to contact me. Thanks.